Okay, so first let's address the detection part. If I play the game, you can see my trace is not at my feet level. If you look above, there it is. So if you guys remember in the blueprints player, and in that player we were using the interaction manager. If we check the interaction manager, you can see we are detecting the interactables, and if we check this function, we have set the Z to 15. So my point is, when you are working with landscape, or for that matter with anything, there is a high probability that your Z can change. So there is no point of keeping the Z fixed, that is 15. Instead, you should use this Z to get the feet level. Why I'm saying this is because the old map was this one and everything was perfect, and we did not consider the height at that moment. And the second point that I want to address is that you are using event tick to continuously detect the interactable. Of course, only when you are not interacting. But think it from the AI perspective. AI is not going to use the trace. Instead, you should just tell the AI that, okay, just get to this interactable and interact with it. There is no requirement of trace because the direction of trace is dependent on the controller's direction, and AI does not have a controller of its own. It's been controlled by the AI controller, which is completely dependent on your logic. So whatever you will write, it will point in that direction. So there is no point of checking continuously whether we are looking at a interactable or not. So the second thing that we have to fix is that this interaction manager should support your player and your AI implementation. So that is clear that this continuous detection should be done in the player blueprint or player class, because this is what is being controlled by the player controller. Rest other should use some other technique to get the interactable, or if your mission or your quest demands to interact with some specific interactable, then you should get it in some other style. So this is the second point that I wanted to address, that this interaction manager should not perform the detection for you, because now we have to make it generalized. Let's address the third point. In the interaction system, I told you we use tag manager. The custom tag manager that we built, if I quickly give you a glimpse for those who are not following the series, there is this tag manager which keeps track of the tags without using gas. So there are 3 tags that we are tracking. You can see in the project settings, we have the gameplay tags, and in the manage, we have created the state. You can see in the locomotion, you can check whether it's running, sneaking, or walking. And in the movement, whether you are falling or moving. And then in the stance, you have crouch, prone, and stand. So these are the 3 states that we are controlling with our custom tag manager. And whenever someone wants to know this information, they can just bind the event via this add tag listener. So as soon as they call this function, they will be notified when the tag has been added or removed. And once they are done, they can also unbind by using the remove tag listener. Okay, so you can send your event and it will unbind it. So that is the cleanup function we created. Now in this tag manager, you are heavily relying on the player input, because if you check the BP player and in the event graph, you can see when you receive the movement input, you add the tag of moving, right? And if I go further, if you are pressing the crutch, that is your control key, then also you are calling this tag manager to add this crutching tag. And when you uncrutch, you remove it again. Now, why we did this way? Because we do not want to constantly tick and check whether the character is scratching or not, whether the character is moving or not. That is little bit expensive, because this is something that is required for the communication between different actors and the player. It doesn't have anything to do directly with the mechanics. That is the reason we have connected with this event-based approach. Then same applies for running. You try to add the running tag and then you try to remove it. So all this is good, but my point is that AI does not have the input actions. They are going to use the AI move to command, which is going to decide whether your character is moving or not. Of course, there is one way that in the state tree or in the behavior tree, you can get the tag manager and then you can bind the listener, and then the interactables can carry out with this approach because now AI is having the tag manager. But there is a catch. This tag manager, first you have to add the listener so that you can receive the event. Second, you have to clean it up. So there are two steps that are happening when it comes to the interaction with any interactable. First, you have to bind, then you have to unbind. And that too, if you have more than one people allowed for the interaction, it can go little cumbersome. The reason I'm asking you to not get the components in the other actors, because components are a way to encapsulate the logic that is part of your character. The actors should only speak to the player, not to their components. Everything should be centralized at your player, and player has the full flexibility where it wants to keep the logic. So that is the reason I'm saying that you should avoid using components, because this is a tight coupling. Here you are heavily dependent on this tag manager, and tomorrow if you change anything in this, then you have to modify each actor that is using this tag manager. That is not healthy if you are making a big game. Okay, does that mean the tag manager was a waste of time? No, the tag manager was not a waste of time. It is one of the ways you can use tags without using gas. If your project is small, if you are doing simple stuff, you don't need to overwhelm your code base with the gas implementation. You can stick to the tag manager component. You can bind the listeners and unbind it just like you do with the event dispatchers. The only flexibility it brings is that you do not have to cast. Okay, great. So this highlights our another problem. So we have to remove it. Now, how do we remove it? Is via gas. So now people who are going little more ahead, we already have the gas ability for the interact. As you all know, we are using multi-tap system. So there is this single tap, then you continuously listen for the tap events. That means you can have more than one tap. If you press the tap second time, third time, fourth time, it will keep calling this tap, and the interactable will decide what to do at the end level of tap. Then we have a hold functionality. So if an interactable like bench implements the hold E functionality, then you can also go for that. So this is the gameplay ability that is keeping track of everything. Now the beauty of this gas and specifically the gameplay ability is that they have this small asynchronous nodes. Now what happens if this ability ends? That means if the interaction is over, this ability will end and all these listeners will be cleaned up automatically by the internal system of Unreal Engine, right? So that is a savior for us because we do not have to take care of binding and unbinding the listeners that we were having in our tag manager. Okay, so that is the second step that you should take once you understand how the gameplay tag communication works. You can use these asynchronous node. Remember, there is a clock on such nodes which are asynchronous, which continuously runs based on the configuration you do here. They are also like listeners, but they are binded and unbinded automatically by the internal system of gas. You do not have to worry about it. So your code base is more modular and clean. That's the most important thing in the programming. So what is the target of this video? We are going to generalize this interaction manager for the AI and our player character. And second thing is we will decouple from tag manager and will try to use gas in the interaction system that we have built. Okay. And the last thing that I want to address, which I do not want to do in this level, instead I would like to go for third person map. You see, if I play the game, there is my sphere trace by channel. Now it is going to detect only what is at this level. And if you are keeping something at a little height, then you have to add a box collider and you have to make sure that it is up to ground level height. That is not something we want. Instead, the trace should be able to detect what is kept at the bottom, what is kept at the top, what is kept at the middle. So Like for example, this shelf, you can keep a lot of items at a different height. And in this case, the trace positioning is not compatible. It's not reliable. So we are going to use the sphere trace because I already explained why you should not use line trace in your interaction system. Instead, you should use sphere trace. The only change we are going to do is that we are not going to start the trace from the feet level. We are going to start the trace from the camera. When I say from the camera, I mean in the player. Let me get the viewport. We are going to start the trace from here, and this will allow you to aim the trace via this crosshair, and you can pick or interact with that item on which you are pointing. Great. So let's do it. In the player, we will do the detection, and once we detect an interactable, we are going to call the interaction manager to handle the hit. Okay, that is the job of interaction manager. It only manage for you. Okay, so you can pass your work to the interaction manager, but you cannot initiate the work in such components. Of course, exceptions are always there. Great. So what we will do, we will first work on the trace part. So this is the detect interactable function that we were using. Now we no longer need it. So what I'm going to do, I'm going to go for event tick, and we are going to go for our blueprints, BLIs, and we are going to go for BLI character. And in this, we will do interactable trace, or let's rename it to, it should be trace interactables. Okay, that is much better. Now every player, whether it is an AI or the player, it will have this function, and then they can have their own implementation of detecting the interactables. So player is heavily relying on the player controller and the camera, but the AI characters will not have any camera. So there is no point of starting the trace from camera for the AI. So I'll keep this function, and in the return, okay, and if I compile and go to my BP player, so we are going to go in the blueprints, character defaults, and you have the trace interactable here. Now we do not want this to be an event because we have to return the result, and the result is this, the hit result structure. So we will go to BLI character and we will convert it into a function by adding a return node. If you do not see the node, just add an output and it will be visible. And I will write hit, and let's make it more precise, hit result, and we'll say hit result structure. Okay, compile and save all. And now you can go in your character defaults, you compile, and the trace interactable function is present for you. Okay, so let's save all and close everything in the right. We go in the player, and now you can check in the override, that is trace interactables. Okay, so in the trace interactable, we will go for sphere trace by channel, and the channel is visibility. You put the out hit here, and now we need to know the start position. So the start position, we will get the camera, we will get its world transform, and we will split it. This is the initial location, so that is start, and we will start from here and we'll go up to 500 meters. So we have to add in this direction. So to make the direction or to get the forward vector, we will use the rotation, and we will say get forward vector, and then you can multiply by 500. This will give you 500 in one of the direction in which your character is facing. So I will add it, and this will be our end. And to avoid the error zone problems, like I mentioned in the start of interaction system, we will keep the radius to 15. That is the entire idea of having sphere trace instead of line trace. So we will hit compile and we will save all. In the event graph, now you can call this trace interactables. Now remember, the trace should only happen if you are not interacting. That means you are available to interact. And the second point above all this is that the ability system and the interaction manager, these two are supposed to be part of every character, be it your AI or be it your player. So now I'm going to make them modular as well. So instead of putting them into your player, we will put them in the character default so that the AI characters can also derive them. So we will add the ability system first. Then we are going to add the interaction manager, because now we are going to make them generalized that supports both AI and the player. We will save all, and if you now go in the player, you will see interaction manager 1 and ability system 0. So we do not want them. What I will do is I will select this ability system and I will delete it. I will select this manager 1 and I will delete it. Now we have this interaction manager and the ability system, which are derived from the character defaults. This is our base character class, and you cannot delete them from here. Okay, so if I compile, let's handle the errors. If I go in the target, we have to provide the interaction manager. So let's quickly get them. Okay, let's hit compile. 3 more remaining. Okay, we have to get the interaction manager here, here, and here. Okay, let's hit compile again. Save all, and the errors are gone. Great. So this is done for the replacement part. And now we can locate our event tick in the event graph. There it is. Now what we will do, we will go for a branch node. We will check whether you are interacting or not. So we will check has tag, that is your interacting. So event interacting. So if you have this tag, then we will not perform the trace. In the true, will not do anything. But if it is not present, then we will go for trace interactable. You can also go for not boolean if you like to do it in the true branch, not in the false. That is also one way. Okay. And now once you detect the interactable, you are going to pass this hit result as is. So what we are going to do in the interaction manager, you are going to remove this tick. So the component is no longer going to tick. So what I'm going to do, I'm going to delete all this. And now I will create a custom event, process hit, and we'll connect it here. And now we will pass this input here. And if you compile and go to player, you can get your interaction manager and you can say process hit. Now it's completely your call how you detect and get the hit. Once you have got the hit, you can pass it to your manager and it will take care of the outline and everything. Okay. The second small thing that I want to do is this highlight. So whenever your trace hits something, we do not want to highlight that interactable if it's AI, because the highlight part is for the player. It's not for your AI characters. They are controlled programmatically. So what we will do, we will add one more boolean, that is b avoid highlight. So if you send it true, then we are not going to process the highlight part logic. So what I'm going to do here is that I will add a branch node. I will add a sequence node. I'll disconnect this second pin and I'll connect this here. So we are going to store the hit, but this highlight part is optional and it will be decided by this. Okay, you can remove this execution pin. So if it is my player, then it will be false. But if it's your AI characters, then it will be true. That means it will not ask the interactable to highlight itself or change the material or something like that. Okay, so this is now generalized. And now you are going to give the ability to the ability system. So whoever owns this interaction manager will have the GA interact, that is your gameplay ability. Second thing, this reset character is part of the character. Technically, if you see carefully, you are getting the owner, you are getting the skeletal mesh, and then you are getting the animation instance, you are setting the animation, you are configuring the movement. Remember, you are calling this reset in the interaction over, which is something that has been initiated by the player itself. Let's park this for now. First, let's resolve the tracing part. In the functions, we will look for trace interactables and we'll set it to draw debug type for one frame. Compile and play. Now you can see there is your trace. Okay, now you can point at anything. See, like this. Great, so we have this working. Now what I'll do, I'll go to my character defaults, and in the event graph, let's close all the other tabs. And in the character default, you have this configure movement and the move to, but we haven't connected these pins. We forgot that, so we will connect them. Okay, so this was the mistake or missing work that we did not do. And save all. And now in the class setting, we can add the BLI receiver that is basically going to notify when the interaction is over. So we did not implement this interface events and functions. You can see on interaction denied, interrupted, and over. So if you check your third person character, the duplicate work that we had in the past, you are calling these events. And in this event, you are processing this reset character and you are again calling back the character. So you could do this in the character itself. So what I'm going to do, I'm going to copy this entire thing in the character defaults and I'll put them here. And I will make it reset character anim state. That is far more precise and better. Now you don't need this skeletal mesh like this. You can immediately get it from here. And you can connect it with the animation instance. And it is okay to call this function and not store this reference because you are not going to call this every tick or every second. It will only be called once you are done interacting. And we need to configure the movement. So, and we can do configure movements, which is part of character default. I'm going to plug this and we can delete this one. Okay. Compile, save all. And when the interaction is interrupted or over, first we will call this function to reset character animation state. Okay, first we should call the interaction manager. Let's get the interaction manager, interact over, call function, and then we will get on interact interrupted, call function, and there we go. And once we are done, we can reset the character's animation state, which is to remove the mirroring tag and configure the movement back. So compile and save all. Go to interaction manager. Now we no longer need this. And we do not need this either. And this send gameplay event to actor can also be removed. And you can cut it, put in character default, and you can say get reference to self, and you can pass this to actor. Okay, this will notify the gameplay ability system where our interact ability is listening. Okay, so let's save all and go back to interaction manager. Now it's simplified a lot. So now you are no longer querying anything externally every tick. You are only calling them when you need it. This get owner is happening only once. This get owner will only happen once you release the key. And now since we are not going to use tag manager directly, I'm saying directly, then we can go in the blueprints and in the tag manager, in the exclusive add, you are adding the tag in the gameplay tags. Now you can directly add them into your ability system. Okay. So this is the reason why I created every function separately. Now you see, you just have to replace in the add tag and in the exclusive remove function. Only two places. Rest of them will execute their own logic. They have nothing to do what is happening in the add or remove. So this is the beauty of maintaining the modularity via creating single responsibility functions. So we have exclusive remove and the add tag, and in the add tag there is exclusive add. So this is, we are going to remove, but for this we have to go in the event graph and we have to get the ability system. So we will get owner, and instead of querying every time, what we can do in the event graph, we can promote this to variable and we'll say owner. And now you can plug this here. Great, compile and save all. In the exclusive add, we are going to remove these two, and we are going to get the owner, and we will add loose gameplay tags. Now you can decide whether you want to replicate it or not for the multiplayer purpose. And for this, we have to split this and connect it like this. All right, so we compile, then we go to exclusive remove. Now here we are not going to use this. Again, we are going to get the owner, remove loose gameplay tags. First, we are going to delete this, and we are going to connect with the gameplay tags by splitting it. Okay, and we are going to get this owner here. Then we are going to pull this a little down, and we are going to copy this, remove this gameplay tag, and plug this false pin here, connect this one here. The gameplay tags is going to be gone, and this tag is going to be part of this one. We are still keeping the tag manager. All right. So we compile and save all. Okay, so your tag manager is now adding the tags in the ability system. So now we can right click and find the references, and now you see there are a lot of references. So to make it more precise, we want to search for get gameplay tags, which is this variable that we are trying to get. So there is one in the remove tag function and another one in the exclusive remove. So we go back to remove tag, and now we do not use this gameplay tags. Instead, what we will do, first of all, let me close all the other tabs. I'll go to event graph and I will get the ability system component. I'll promote to variable, and I'll say owner ASC. I'll plug this here, compile, and now we go to remove tag and we will remove this. We will get the owner's ability system, get the owned gameplay tags. This is the function, and we are going to check whether this tag is present in this. Okay, so we are going to use the ability system now. So I'm trying to include gas a little by little instead of taking it completely from ground up. We will do the same thing here. Let's copy this and paste it. Why I'm not storing the reference of this own tags? Because they will change continuously. So we have to get when we want instead of caching them. Okay, we hit compile and we save all. Now you can delete this gameplay tags. Great, so we have deleted. We will save all and we will compile. Now your tags will be granted to the ability. Okay, so if I go in the player and in the event graph, what I can do is add a sequence node, and in this I will print the gameplay tags. So we will do ability system get gameplay tags, and we will right click and split it, and we will do for each loop, and then we are going to add a print string and we are going to connect it. And also in the character default, we will grant the standing tag by default. So we will get the reference to self, and we will add loose gameplay tags, and the gameplay tag is split make, and we'll say standing, right? And we will connect it. Of course, you can replicate it. So compile and save all. So we have granted the standing tag. And what we can do in the character default in this capsule, you can say hidden in game true false so that you can see the capsule to debug. You can see walking, moving, and standing. If I run running, moving, standing, walking, moving, standing. If you stop, it is just standing. If I crouch, you are in a crouch state. If I start running, it does not get up and run. It is showing the running tag, but it is not running while standing up. Tag manager, there is a notify tag change function. So if you start running, We will check whether you are applying the running tag. Then we choose the running. We pass it to the gate function. So we can also use the owner here now. We can remove this and compile. And now we should check the change gate. All right, so we did not change the current gate that was supposed to be changed. So if I find the references, we are not setting it. So we should set it before calling this gate changed. So what I'll do, I will set the current gate with the new gate. So I'll duplicate this, connect it here. So running, moving, standing, walking, crouching, running all of a sudden in middle of crouch state. Okay, everything is working for you. So this is how you use the ability system to get the tags. Okay, I deleted a little too much. Let me remove this, and this one. So now your trace is working. You are able to detect everything. We can remove this from the character default now. And now let's implement the interface of receiver, which was not implemented. In the class settings, let's also make the capsule hidden again. We can go to class settings and now we can remove this interfaces. You see we have BLI receiver. There are 3 events. If I go to the character defaults and look for over, interrupted, and everything is good now. If you check the interaction manager, I'll bring the door first. I'll get this single base door. You can see it is now interacting, but you see now you are not able to move. Okay. But before detecting it, I want you to recall one thing, that once you have detected the hit in the player, you are asking to process the hit. You process the hit, and when you press E, you are going to call the interaction manager's try interact, which is going to activate the ability. And this is not good, so we will get the ability system instead. I'll store the owner and the ability system because we are using quite a lot here. The 1, the 2, okay? So we should not be fetching the owner again and again. So I'll promote this to variable. I'll say owner, and I will also promote this to owner ASC. Okay. So now you give the ability system the ability it needs. You compile, you go and try interact. Now you can get the owner's ability system and you can connect this directly and remove these two. You can get the owner as well now and connect this here and here. Right? Compile, save all. Now let's have a look at our ability. Once you start the ability, you are just double checking. Remember this get actor from Trace? This was for multiplayer especially because there can be server delay or something like that. And in that case, if the actor is destroyed or interactable is gone, then the ability should not be proceed. So this is the final step of validation whether the interactable is still present or not. So we are not going to use this actor from Trace. Instead, we are going to call this function which we have implemented in the player, that is your Trace Interactable. So we are going to call this, and in the interact, you can get avatar actor from info, and I will promote this to variable. I will say owner, just trying to avoid calling this repeatedly, and we will trace interactables. This is the final call. If it exists, it exists. If it doesn't, then it's gone. So we will connect this blocking it here and we will connect this here. Okay. Now you can get this owner here. You can connect with this, delete this one. Anymore. Let's get the owner here, connect it with this, connect it with this, connect. Okay. All set. Let's compile and save all. and there is your gameplay ability ready. You can see you are able to detect the hit. If I press E, it opens the door, but you are not able to move. And the reason it is not working because we overrided the functionality of on interact over and interrupted in the player. So we have to inherit from the character default. So we don't need to do this in every character's class. So what we can do is just delete this from the player. Compile, go to character defaults, and now you can put them under interaction receiver events. Okay, and also we can call the on interaction denied. Okay, so we compile and save all. Now we again play, try to open the door, it opens. Now we can go forward. Okay, you can also try your bench and everything, but let's do that in the level 1 map. You have your bench, and let's get the door and let's get the door. And if I play, let's try the door. Key goes in, it unlocks. Now you can open the door. Okay, and you can also sit on the bench by aiming at it for 0.2 seconds, and then you sit. If you want to get up, you get up. And before we wrap up this episode, let's resolve the tag manager in the bench. So you see, once you sit on the bench, you start listening for the movement input. And then as soon as user press a movement key, you get up from the bench. So I want you to think it from a long-term perspective. There can be many interactables that have different demands of exit. So for example, let's say you are mining something. Let's say you are mining some crystal. So you hold E and you keep mining till you gather up to the threshold, or you want to stop the mining once user press E or press W, like that. So there can be many use cases where a certain interaction is ongoing and you want to allow exit after a point. So in this case, first user has to sit and then we will start listening for the input or change, that whether user wants to get up or not. So for this to work out at a generalized level for all kind of interactables, not just sitting on bench, what we will do, we will go in the third person blueprints, BLIs, and in the BLI receiver, here we will create a function that is on exit ready. Okay, and on exit ready means this function will be called when the interactable is open to listen for the exit condition. Let's say if you are opening a door, everything will be done automatically. Like once the door opens, interaction over will be called and the interaction will end. But in case of pushing the cabinet, or for example, you are sitting on the bench, you will fire this function from the bench and you will notify the player or the AI character, that is basically the receiver, that we are ready to exit the interaction, and as soon as you tell us, we will complete the interaction. Okay, so this is specifically for ongoing interaction. You can also write a description here just to keep track of what you are doing. Like for example, here I can say ready to abort or finish the interaction. Okay, so the bench will call this, and now there can be different type of exits. Like I said, if you are sitting on the bench, you will listen for the movement input. If you are pushing a cabinet or doing something else, or you are dependent on some other type of interruption, you will have to handle that, and you cannot create everything in the interactables. So that is the reason I created this function. And what we will do, we will first add the interactable. Okay, and this is the actor. So the interactable will call this and it will pass its reference, and then it needs to pass what type of rule does it follow, or I must say what type of event it wants. So what I can do in the enums, I can create another enumerator, enum interaction exit type. Okay, and we open this up. First one will be auto. That means we do not have to do anything. It will automatically interrupt, or it will automatically over by itself. And second is the movement. So we will say movement input. Now you can add some other stuff or some other input actions, and you can give them the name, and then you can handle it in your character default. So I will save this, and I want to know exit type, and we will say interaction exit type. So in this case, it is movement input. So I will compile and save all. Okay, and now we will go to bench, and now we don't need to listen to this. And instead, what we will do, we will start listening for the input. If we open this bench interaction, you see, once you sit, then you would like to start listening for the input, because as soon as you sit on the bench, then you would be able to get up and play this part of the animation in the montage, right? So first you have to sit. So in this process, if you are pressing the key, it doesn't matter. We are not going to consider that as an exit. Only after you cross the idle start, then you are allowed to get up anytime. Otherwise, we will keep looping this animation like this. So if you press input at any time in between this, we will immediately transition to idle end and it will get up. That's the idea, right? So we will go in the bench, and now we can remove this tag listener. I can remove this, and we do not need this custom end. You see, we are jumping to idle end as soon as the movement key is pressed. So we can remove this and this as well. We will create a function, and we will say handle, or let's say process notify. More precise, process montage notify. And here we will say, first of all, the notify name, that is our name. Then we would like to know the reference of player, and it will be actor object reference. And now what we will do, we will go for a switch. So if we look at this, we have idle start and idle end. We will add two strings, idle start. Please mind the sensitivity of the name. So let's go and copy it from the notify. Select this idle start and copy it from here. You can see S is capitalized and I placed small, which is wrong. So let's fix it, and actually let's go for idle end, copy it and paste it in the second one. Okay, so this one is start and this one is end. Okay, so let's go back and copy this logic. Let's cut it and paste it here. So this part is when you reach to the idle end, which means you want to get up, and we can remove this as well. And you see, you have to pass the animation instance. So what we can do, we can create a function in our interface so that we don't have to get the anim instance from the skeletal mesh. So we will decouple here by going in the BLIs here, and in the BLI character, we will add a function, and we will say montage jump to section. This way you can directly call this function via character reference, and you will not have to get the skeletal mesh, then the animation instance in the interactable. So we will do section name, and we will change this to name, and we would like to know the montage, and we can search for anim montage. Okay, so now you can compile this, and you can go in the blueprints, character default, and in the interfaces, you will find montage jump to section on the top. And now what you can do, you can get the mesh, get its anim instance here. And now you can say montage jump to section, and you can pass the section, the montage. So now you no longer need to put this inside the interactable. So this saves you from that trouble. and this is our player. So let's actually remove this one, and we would like to go for on task jump to section, and we would like to first check if the movement key is pressed or not, because if the movement key is not pressed, then we would like to go back to idle start so that you can keep looping in this area. Okay, so that is what we are doing in the idle end. As soon as you reach to the end, we will check if you press the movement key. If not, then we will go back to idle start so that you remain seated. So I'll say idle underscore start. Please mind the sensitivity of the characters, and we'll say it to true. Okay, so this is for the idle end. Now when the idle start happens, this will also move it to idle start, and you will again get the notification. And you will also get the idle start when you first time sit on the bench. So there are two cases. So what we will do, we will go in the event graph, and I will create a custom event, and we will say setup movement listener, and we will add a variable b is, let me shut down my camera. Okay, so b is exit listener ready. Why I'm doing this is because if this is not ready, then only I would like to initialize it. So not boolean. If the exit listener is not ready, then we have to make it. So for this, we will get our character. So we need to get our player, and we will call on exit ready. Okay. So this has to be done only once. Remember, you will constantly call this idle start if you keep looping. So that is the reason I kept it here. And exit type is the movement input, and the interactable is the reference to the self. Okay, compile and save all, go back to process montage notify and call that setup movement listener. And the player is this. Great, so we solved this problem. Now we can go to character default, and in the on exit ready, we will double click and we will go for a switch. And now the problem is you cannot implement this in the character default because movement input is something that will happen in the player, but AI will not use any such thing. So what we are going to do, we are going to remove this and we will let our child blueprints implement this. So first is our player. So we will go in the player and we will double click on the on exit ready, and here we will do switch on interaction exit type. And now here first we will check if you are interacting, because if you are not interacting, then there is no point of doing this listening. So I will get my ability system and I will check has matching gameplay tag interacting. Only then we will set up our listener, and we will say wait gameplay tag add to actor, and the tag is movement, that is your moving tag. Okay, and only trigger once. And if the tag has been added, remember in the tag manager you were using ability system now, so you added the loose gameplay tag into owner, which can be read by the ability system. So now as soon as you press your W key, your tag will be added, and then this will listen for that. So as soon as it is added, we will call this interactable, which requested this thing. So we will go for, and we have to notify. So in the interactable, we have to go in the BLIs interactable, and we'll create another function and we will call it abort interaction. So this is something that is coming from the player, and we will ask for the player information, and that is our actor. So let's compile, save all, and let's add a return node as well, and let's say nothing but a result. It's a boolean. Compile, save all, and we can go to bench, and in the interface you will find abort interaction, and here you can capture that. So what we'll do, if you press the movement input, then we would like to jump, So we will get player montage jump to section, and that is your idle end so that you can get up, mine the characters. And the montage is the bench interaction. And we will also update our is movement key pressed. So we'll say to true and we'll set it to true. Save all. So what will happen? You will first abort. It will jump to the idle end. As soon as it goes to the idle end, the on interaction over will be called once you get up from the bench. And when you will call the on interaction over, you will notify the player and the allowed to interact will be set to true, movement will be reset, and the on interaction ended, you will push the actor a little bit. So this is all we had to do. And I go to BP player, and now here I can call abort interaction. And the player is the get reference to self. Now, the reason I did it in the player is because if you are doing AI, then you will have your state tree or behavior tree and you can listen for that input. Okay. And if you are not able to figure it out, it's okay. In the next coming episodes, I will show you how you can capture that in the state tree or behavior tree to resolve this. Okay. And one last thing, that is we have to reset the exit listener ready to false. And here we will set it to true because now we have notified the receiver and it will make a call. So this is only supposed to be done once. So we can compile and let's double check our process montage notification. You will set up the movement listener, and in the event graph, you can now connect with the notify begin. So we will call this and we will plug it here. This is the notification name, and you need to reference the player. So you can get this, the player. Okay. Now this thing can also be done in the player, so you don't have to get the skeletal mesh, but this has to be done in C++. I am parking it for now, but we will do it later. So now if I compile and save all, I can play the game and I can try to sit on the bench by holding E. It sit, and if I press W, it gets up. No tag manager, no coupling. Okay.